What's up, guys? Today I'm gonna do another LeetCode problem. Haven't been feeling that good recently. But I thought get my mind off things and just do some LeetCode. So let's start. So this is 2966. Divide array into arrays with max difference. You're given an integer array nums of size n, where n is a multiple of 3. And a positive integer k. Divide the array nums into n over 3 arrays of size 3, satisfying the following. So how many arrays of n divided by 3 will there be? Maybe they're called triplets, like number of triplets is equal to n divided by 3. The difference between any two elements in one array is less than or equal to k. The difference between any two elements. Interesting. Return a 2D array containing the arrays. If it is impossible to satisfy the conditions, return an empty array. So I guess we're just gonna have a result array, process the result, and then return result. Okay, I don't care about that. Something tells me, so first of all, since you could just, they're not like contiguous elements, right? They kind of just want, you can pick like what values you want from the array. So I don't know why I'm saying that, but okay, so when you do something like that, okay, like when you don't really care about the actual order of the elements, having the numbers array be some like random like combination like this and so on and so forth might be disadvantageous. There might be a better way we can do it, and that way might be like sorting this array. Now if I were to sort this, and the reason why we want to sort it is because the order doesn't matter, right? So sorting it can only help. And what I'm thinking right now is that if they give us a k, right? So first let me sort it and then I'll talk more about it. So it'd be like 1, 1. I'm looking at example 1, 3, 3, 4, 5, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 9 elements, 9 elements. Cool. And then if they give us a k of Okay, let's just say they gave us a k of 2. Um, then we want to look at triplets, right? So we can look at the first triplet, and because we sort it, like if this triplet didn't work out, then there's no way that this triplet skipped over here wouldn't work out. If that kind of makes sense, since they're all sorted. So we are kind of it. I don't know what type of topic this is. Like maybe it's some sort of like greedy approach, but it's kind of like, yeah. But let's run this through. So if we did 113, let me just write that down right now. So 113. And then since I guess it's hard coded that there's 3, we can just do how many comparisons? Like 1, 2, 3, 4. The difference between any two elements. So I guess, oh, just so, because I'm a little bit confused, let me just hard code it for now. It would be like 1 minus 1, which is right here. But then you could also do the reverse of that, which is just 1 minus 1 again. We could do 1 and 3. So we do 1 minus 3, we could do 3 minus 1. We could do this combination, same thing. 1 minus 3, 3 minus 1. And I think that's it. So I think there's 6 possibilities. 1, 2, 3, 4, 5, 6. Yeah, okay, there's 6 different things. And then each of those 6 are all less than k, which I guess we could hard code. So since that works, we can... Oh, it's always size 3. Then we can do this. But why wouldn't one... Because I don't see 133 in the output right here. But I feel like 133 would work, right? Because 3 minus 1 is 2, and 1 minus 3 is like negative 2. And 3 minus 3 is 0. Oh, we divide... We divide the array. Oh, so that means that no two arrays, no two elements can exist in the same triplet. So since we already used 1, 1, 3, we have to go like to there. I guess that like kind of makes sense, right? You just can't... I guess that's the whole purpose of dividing something. We don't use it more than once. So now we have 3, 4, 6. Oh, there was a 5 in this? 1, 1, 3, 3, 4, 5, 7, 8, 9. 4, 5, 7, 8, 9. Okay, so now we can, I guess we consider the next 3. So the next 3 is 3, 4, 5, and then that will all work, and then we consider the next 3, 7, 8, 9. And then I think the greedy part, so this was probably a bad example. Maybe I'll do the... Huh. Okay, that's an interesting example. Is there another one that won't always work? 2, 2, 2, 2, 4, 5. Same thing. We look at the first 3, 2, 2, 2. Those are all less than the k. And then we do 2, 4, 5. 5 minus 2 is 3, so that wouldn't work. 2, 4, 5. Oh, there's no valid division. There's no valid division right here. Oh, since we can't divide the whole array, then none of it works. It's not like, oh, the 2's worked, so we're just going to return the 2's. I guess if... Yeah. This is kind of hard. This is kind of a hard problem. This is kind of tough. I also don't want to sort that by hand. Let me just do nums.sort print nums and then grab example 3. Cool. So this is the next problem. And then this is the first 3, which is, let's write it down. So now I'm starting to think, we just work by 3's. Like, okay, so this is one of those problems that I was really confused about what they're asking. And I'm slowly piecing together that if one triplet doesn't work, we can't just like try the next triplet and ignore this 2. That's not how it works, right? Or else we couldn't divide the array into n divided by 3 arrays. So in that case, we would just stop right there. We have to go by 3 every single time and check if these work. And then we have to check, does this work? And then we need to check, does this work? Okay, and then now that I'm thinking about it even more, I think instead of actually checking like those 6 times, what is like the extreme of this? Like, of course, the best case scenario, right, is after something is sorted, let's just like zoom in on like one of the arrays. The best case is that they're all the same. What's the worst case, right? The worst case is that the first one is the smallest because it's sorted, and then the last one is super big because it is also sorted. So we only care about the first element and the last element in that triplet. And then if the last element, and then I guess I could do x, we could call this x, we could call this y, we could call that z. So if z minus x is greater than k, then we just need to return this, like we are done, not possible. Okay, it's very important. So I think the 2 most important things of this problem is that we're using sort, and then we're also being very smart by not having to check so many times. We just check the last and the first of those 3. Cool. So like I said, the first thing to do is sort it. Now we could do for I in range n. Um, for I in range from 0 to n, do this, print I. I haven't used these before, but I think this was do every 3. Yeah, 0, 3, 6. This is exactly what we wanted. So we want the, remember I talked about x, y, and z? We don't really care about y. So I'll just do x and z is equal to nums at I, nums at I plus 2. Nums at I plus 2. And then if z minus x greater than k, return this. Otherwise, res dot append. Oh, we might as well put a y in there because we're gonna do nums at I plus 1. One sec. Hello? Yeah. No, but I have some stuff.
Okay, so I'll stop by and eat the one that I put
Yeah.
in the refrigerator.
Okay,
Okay.
bye. Okay, so that's xyz. Let's append like array xyz. And then that's it, right? We just need to return res, which I did over here. Let's go ahead and run that. Cool, it worked. If this works, like that'd be cool. Not easy, in my opinion. Even though like the actual code, there's nothing hard about. It took a lot of like examples and just really understanding what the question's all about. Like I went through a lot of iterations of this where I was like, wait, I guess sorting it was like a big discovery. And then another big discovery is that if like if one group of triplets don't work, we need to stop right there because they want to have exactly n divided by 3 arrays. That means all the arrays must work. So I wish they kind of set that in their instructions like a little bit more clear, like every single array needs to work. But I guess running through the test case and kind of thinking about it more helped. Okay, this is just going to be O of n. The space is O of n as well. So yeah, this is just a linear type problem. Yeah, and hope you guys enjoyed. Thanks for watching.